So here now we will discuss about amplifiers. Amplifier, that is operational amplifiers, is referred to as op-amps, are most commonly used electronic devices used to amplify small voltages in biomedical devices. And the operational amplifier amplification factor referred to as gain, which is the product of the amplifier's bandwidth. The same device, when the circuit with a gain of 10 only works up to the frequency of 100 kHz. So the configurations is inverting, non-inverting, integrating, differentiating, buffer and differential. So inverting is active gain and the output has opposite polarity to the input. Non-inverting is active gain and the output has same polarity as the input. Integrating means it amplifies the time integral of the input signal. Differentiating means amplifies the time differential of the input signal. Buffer, that is unity gain, buffers the input with respect to differential loads. Differential means amplifies the difference between two input signals. Circuit analysis rules for op-amps. So the input resistance of op-amp is very high, approximately 1 mega ohm, and simplifying assumption used extensively in op-amp circuit analysis, that there is no current flow into the device. I plus I minus is equal to 0, and the gain of the op-amp is defined as the ratio of the output voltage V out to the input voltage, and this is very small, and the second approximation used in the circuit is V plus V minus is equal to 0, and this is the diagram for op-amp. Inverting and non-inverting amplifiers. So here is the diagram for inverting and non-inverting amplifiers. So inverting amplifier, the positive terminal of the input source Vin is connected to the negative terminal of the op-amp, and positive terminal of the op-amp is connected to the ground. That is inverting. Non-inverting means the positive terminal of the input source is connected to the positive terminal of the operational amplifier. The characteristics is high input impedance, low output impedance, and the biopotential amplifier must be sensitive to important frequency components of the biosignal, and most biopotential amplifiers are differential. Next is the preamplifier. So this preamplifier employees include universal amplifier with special features such as capacity neutralization, current injection, low leakage current, and low DC drift suitable for intracellular measurements. An ECG amplifier with full 12 lead selection and the patient isolation. A transducer amplifier suited for bridge measurements on strain gauges, strain gauge based blood pressure transducers, force transducers. And next is the DC amplifier used in conjunction with standard thermistor probes for the accurate measurement of temperature. Next is the differential amplifiers. It is known as the differential amplifier is electronic amplifier that amplifies the difference between two input voltages but suppresses any voltage common to the two inputs. A differential amplifier is an analog circuit with two inputs V1 and V2 and one output V out. V out is equal to AD into V1 minus V2. V0 is the output voltage, V1 and V2 are the input voltages. AD is the gain of the amplifier. So this is the BJT differential amplifier, and this is the operational amplifier differential amplifier. Next is the chopper amplifier. So when recording biopotentials, noise and drift are the two problems encountered. So a DC amplifier has a shift or sudden peak in the output when the input is 0. So the amplifier circuit samples the analog signal. So the AC amplifier blocks amplifies the chopped AC signal. So here the demodulator rectifier block an amplified chopped AC signal is converted to modified DC signal. Here is the schematic diagram of chopper amplifier. The input DC signal is chopper with the AC amplifier, demodulator rectifier, and the amplified output DC signal. Next is the mechanical chopper amplifier. This is the circuit connection of the mechanical chopper. Input terminal and ground terminal Q as the reference term. Chopper acts as a switch. The entire circuit is short circuited, so input voltage is 0, and the AC amplifier starts receiving the signal from P terminal. So at this stage, the conversion of DC signal to square wave pulse occurs with amplification. After rectification, the rectified signal is filtered and amplified. At the output terminal M and N, the amplified DC output signal occurs. Next is the non-mechanical chopper amplifier. So when light is not incident on the photodiode, no current flows through the circuit. However, when light falls on the photosensor, the resistance becomes low. This system is similar to switching operation. So in the diagram you can see PC1, PC2, PC3, PC4 photodiodes. Neon lamp 1 flashes light and on PC1 and PC2. So light falls on PC3 making the input to flow through it when there is no light on PC1. The amplifier output is an amplified square wave pulse. It recovers DC signal and makes the capacitor fully charged to the peak value of the output voltage. Differential chopper amplifier. So it is a type of chopper used for EEG measurement. It has a transformer. A chopper vibrator connects the input of the transformer. An AC coupled amplifier provides the gain, and the output of the amplifier goes to the filter and demodulator block. Finally, an amplified DC output signal is obtained. This is the diagram for the differential chopper amplifier. Next is the isolation amplifier. This is known as preamplifier isolation circuits. It also helps to isolate the patient from the device. So using the isolation amplifier prevents the accidental internal cardiac shock. So this is the block diagram of isolation amplifier. That is, the input is given to the amplifier, to the modulator, and then transformed primary, that is LED, next to the photodiode, next to the demodulator, then amplifier, again the output. Thank you.